Welcome to this lecture. In this lecture, we are going to be discussed about stack in Java data structure. A stack is logically data structure that can be logically through an linear structure and can be represented in the real life as a pile of plates or deck of cards. In this data structure, insertion and deletions of an items take place only at once of the end, which is called the top. Here you can see we have the three index which is 12, 37 and 99. So this is our top index which is on 12. So the basic concept can be illustrated by thinking of your data set as a stack of plates or books. When you can only take the top item of the stack in order to remove the things from it. So the basic implementations of the stack is also called LIFO, means last in and first out. If I add 99 as a first index, so it will be out as a last index in the stack. So it is to demonstrate the way it access like last in and first out. There are basically three operations that can be performed on the stack. First one is inserting an item into the stack, which is called push. So here we have the index 12 and we just push it into the stack. Then the second number operation is deleting an items from the stack, which is pop. So we are just deleting this 12 from our stack. And the third number is displaying the stack contents, which are peak. So this is called peak here. So the stack class implements a last in first out stack of the elements. You can think of a stack literally as a vertical stack of the object. When you add an element, it gets stacked in on the top of the others. When you pull an element off the stack, it comes off the top. In other words, the last element you add to the stack is the first one to move, means to first one to the comeback of. A stack is a subclass of the vector that implements a standard last in first out stack. A stack only defines the default constructor which create an empty stack, and a stack includes all the methods defined by the vector and adds several of its own. Now we just see the example of a stack, and here we have the class which is stack, and here I just import a library which is java.util, and now I just write static void and show push. Okay, and then here I just write stack and st, and here I just write int a. Here I just open the block of code, so st and then push. So push is new and new is integer which is a, and it's not a comma here, so yes, new, and it's st push. Now system dot out dot println, and the println here is push, and then I just write concatenate a, and here I just close this bracket. Now system.out.println, and the print line here is stack, and then I just concatenate st. So here I just create the operations to show our push. Now static, and it's static void and show pop, and then stack st, and here I just write system dot out dot print, and the print line here is, and it's system out and the print line, and the print line here is pop, and then I just write integer a, which is equal to integer, and then st dot pop, and this is st dot pop. Now system dot out dot print line, and the print line here is a, and then I just write system dot out dot print line, and the print line is stack. So this is a string here, and then I just concatenate st. Now I just define the main method, and the main method is strings and the arguments, and then stack st, which is equal to new stack, and then system dot out dot print line, and the print line here is stack, and then plus st. Now show push. So here I just pushing the indexed, which is, or a element which is 12. Then I just write show push, and the push here is st, which is 50, and then I just write show push, which is st, and it's 66. Now here show pop means first I just add 12, 50 and 60 as an insertion operator, and then here I just write delete for show pop, and then st, and show pop, which is st. Okay, now exceptions, so try show pop, which is st, and then here I just catch the exception, which is empty stack exception, which is e, and now system dot out dot print line, and the print line here is empty stack. Okay, and now here, so here I just add a method, or create a method to pop and push. Now I just run this code. So here the pop is null and the pop is null at the initial stage, we have the stack which is empty. Then, sorry, at the initial state, we have add the value which is 42. Then we push the value which is 66 and then 99. Afterwards, here I just execute the value from the stack. So empty, stack is empty, and then the stack is empty. So these are the push, sorry, the pop means we just delete the values from the stack. Now here we just see the another example of dynamic stack in Java. So here I just write private integer stack size, then private integer and stack array. So here I am creating the example that the stack will never comes to the Stack Overflow case because its capacity will keep increased and it reach to the maximum capacity. So it is very dynamic in capacity here. So integer and then take an integer as a top. So here I just create a constructor to create the stack with size. So public and my, so public and dynamic stack, and then I just write integer and size. Okay, and then here I just write this dot stack size which is equal to size, and this dot stack array which is equal to new integer and stack size. So here close with the semicolon and this dot top which is equal to -1. Now here I just write the method public void and push. So this methods add a new entry to the top, an integer entry. Then I just write if and this dot is stack which is full, and here and stack dot full, and then I just write system dot out dot print line, and the print line here is stack is full and increasing the capacity. Okay, now this dot increase which is stack capacity. Now here and here I just write system dot out dot print line, and the print line here is adding and then entry, and it's a concatenation of entry. Now here after that I just write this dot stack array, and which is plus top, and which is equal to entry. Okay. Now after that, I just create the method, means this method to remove an entry from the top of the stack. So that's case I'm just writing integer, public integer, and then pop for the deletions, and then throws exception, and it's throws. And here I just write if, and this dot is stack which is empty, and then here I just write throw which is new exception, and here I just write stack is empty, cannot remove element. Now after that I just write int entry which is equal to this dot and this dot stack which is array, and the array which is equal to top minus minus, and then system dot out dot print line, and the print line here is remove entry, and remove entry. Okay, and then concatenate entry here. Now return entry, and after that I just create the method to return the tops of the stack without removing it, and our this method was for math for remove an entry from the top of the stack, but now we are just creating the methods to return the top of the stack without removing it. So public long and peak, and then return stack array which is top, and here I just write private void increase stack capacity, and integer, and then new, and new stack is equal to new integer, and this dot stack size. So our stack size is multiplication of 2 here. Now for integer I is equal to 0, and I which is less than stack, and then I plus plus. Now new, and new is stack here, and stack is I, and here it's a stack size, and I which is equal to this dot stack array, and array here is I. Now I just write this dot stack array which is equal to new stack, and then this dot stack size which is equal to this dot stack size. So stack size is multiplication of 2. Now here I just create the methods to return the true if a stack is empty. So public and boolean, which is stack, and stack is full, and then return is top, which is equal to stack size, which is -1. And here I just write public static void main, and then string arguments, and then here the name of the class, which is dynamic stack, and here I just write stack, which is equal to new dynamic stack, and the value of it is 2. And now I just write for integer I is equal to 1, integer I which is less than 10, and then I plus plus means the increment operator, and then stack dot push, which is the entry of I, and then for loop again for integer I which is equal to 1, and I which is less than 4, and then I plus plus. So now the exceptions, so stack dot pop, and then I just catch this exception, so it exceptions E, which is to generate the catch block automatically, E dot print stack trace. Okay, so here I just create the method to this stack empty, and yes, I have no error in program, and I just run this program. So you can see here at the initial stage we are just adding the value which is 1 and then 2. So I just add 2 indexed, and stack is full, increasing the capacity. Then we are just adding 3 and 4. Then stack is full, increasing the capacity. So you can see here we just write that we are just enter the 2 size stack here. So after that it increasing the capacity, and then 5, 6, 7 and 8. So just double of the size of stack means, which is 4, 4 integers, yes. Then stack is full and increasing the capacity when, and then we just add the 9. You can see here it's up to 9. Then we just remove our entity which is entry which is 9, 8 and 7, because it is stack. So this is first in, then second number, third, 4. So first in and last out, and last in first out. So first of all I just execute 9, then execute 8, and then 7. So this is an example of the dynamic stack in Java. When we just listen or hear the word of stack, so example in our mind which is the towers of Hanoi. Now we just see the example and see what is the towers of Hanoi. The towers of Hanoi is the mathematical game or puzzles. It controls it consists of three rods and a number of discs of a different size, which can slide into any rod. The puzzle starts with the disc in a next stack and ascending order of the size on the one rod. The smallest at the top, thus making a conical shape. The objective of the puzzle is to move the entire stack of the another rod, obeying the following rules like first of all, only one disc must be moved at a time. Each move consists of taking the upper disc from one of the rod and sliding into another rod on the top of the other disc that may already be present on that rod. No disc may be placed on the top of a smaller disc. Mean if a disc is bigger than another disc, so no disc will be top of the smaller disc. Now we just see the diagram of the Tower of Hanoi. As you can see, the rule number first, the one element on the disc must be moved at a time. Then each moves consist of taking the upper disc from one of the rod and sliding into another rod on the top of the other disc that may already be present on the rod. No disc may be placed on the top of a smaller disc. So here you can see we have the three step means the three step Tower of Hanoi. The first one you can see here, it's moved to the destination. This is our source, this is our destination, and this is auxiliary. So we are moving our this tower from source to destination. So this is the process. So here you can see the smallest element move to the destination, then auxiliary, and then it's moved to destination, then source, and then destination, and then destinations. So this is the example of the Tower of the Hanoi. Now we just see the programming example of the Tower of Hanoi, and we solve it by using the stack. I just create a class which is the name of Tower of Hanoi. Now here I just write private and then static and write my or dynamic stack, then array, and then write tower. Now public static void and then Tower of Hanoi. And the Tower of Hanoi is integer, which is a number of n. So the any number here. Now I just create a three stack Tower of Hanoi. So I just write tower which is equal to new and this one dynamic stack and then the for. Now for and the integer I which is equal to 0 and I is less than or equal to 3, and then increment operator which is I plus plus. Now tower the array of I which is equal to new and dynamic stack and then element of 4. Now for integer t which is equal to n, so n are the numbers of this integer and d is greater than 0 and d is decrement operator. First I just create the stack of 3 tower of Hanoi and then I just writing the decrement operator, and here I just initialize means add disk d to the tower number 1. So here tower is the 1 and then dot push and which is new and integer and d. Okay, now show tower and states which are n, 1, 2 and 3. So it's move n disk from the tower number 1 to the tower number 2 using 3 as a intermediate tower. Now I just write public static void and show tower states which are int n, int x, int y and int z. Now if n is greater than 0, so it's 0, and exceptions are try which are show tower states and n minus 1 and then x, y, z. Now here I just move d from tower x. So integer d which is equal to integer which are tower x dot pop, and now I just move tower to the top of the tower y. So tower, not move tower but element, yes, y dot push, and here the entry is d. Now system dot out dot print line, and the print line here is move disk and then concatenate d and plus from tower, and then I just write concatenations of x and to top of tower which is y. Now show tower which is states and then n minus 1 and z, y and x. Now here I just write catch, and catch is an exception and its exception which is ex, and after that I just write the main method which is public static void main and string and arguments. Now here I just write system dot out dot print line, and the print line here is running 3 disk problem. Now here we just run our 3 disk problem and tower of, and here it's Tower of Hanoi. Okay, and these are the three disks. Now here I just create a class which is my dynamic stack. Okay, and here I just write private integer stack and the size, and I I just already write this class, so there is no need of writing this class again. So this is the dynamic class. Okay, so I just run this Tower of Hanoi now, and you can see first of all it is running the 3D problem. So I think this example is mixed with dynamic stack example. So, and here I just write the stack is full and increasing the capacity. It's the same here, and then system dot out. So I just remove this system dot out dot print line, and then pop integer means integer pop throw exception, and then throw same like this one. And here I just write just not right here, so long peak, and it's a return, and the return is the top here, and then the private, and then string and the size here. So now the boolean, and then the boolean size, stack size, and add the last public static void, and now I just run this code. So new stack, so local variables, so the field here, and now just check, and yes, I just removed this one, sorry. Like we just remove entry, means from our first tower, means source to destinations, and then I just removed second one to the source to auxiliary, and then here after that I just write move disk 2 from tower 1 to the top of the tower 3, and then after that I just move disk number 1 to the tower of the 2 to the top of the tower 3, and then I just move disk number 3 from the tower number 1 to the top of the tower number 2, and then move disk 1 from the tower number 3 to top of the tower number 1, and move disk 2 from tower number 3 to the top of the tower number 2, and then move disk 1 from tower number 1 to the top of the tower number 2. So this is an example of the Tower of Hanoi with Java. So thanks for watching this